All right. Welcome everyone to very interesting topic, a very important topic in Swift. And this is in Unit 2, and it is in the UI kit, lesson 3. This lesson is about structures. Now, you already taken object-oriented programming and object-oriented analysis and design. For you, it might not be as difficult. But for people that are not familiar with this concept, it might be challenging, all right? So what are structures and why do we need structures? Structures are custom data types. That means I can create my own data types and I can make them anything that I want. Now, as you remember, in Swift, there are already data types available for us to use. Strings are data types. Integers are data types. Booleans are data types. Floats and doubles are data types. But if we want to make our own custom data types, we use structures. Now, let's take the int, for example, an integer data type. Integer data type is a simple data type. We usually use it to store whole numbers. But sometimes in real life, there are more than just simple data types. I'll give you an example. A student, if we want to represent a student in our system, a student have a name, has a first name, has a last name, has an address, has a phone number, has a major, has GPA. So there's a lot more things that we want to know about a student, not just simply their age or just their name, right? So this is one example where you can use data types. You can use data types in real life, employees. An employee can have a lot more information that is needed by the organization. For example, you can say an employee has an employee number. It has a position. That employee has a position, or she has a position, right? They have a phone number. They have a salary. Could be employee type. There are so many things that you need to know about a particular employee. So that's where the power of structures comes in. Now, in addition to that, in the next version of Swift, instead of using UI kit, there is another thing called Swift UI. And Swift UI, and if you search on YouTube, I'm sure you found some stuff about Swift UI. That is all about structures. So you need to be very, very familiar with structures in order to move to the next step, which is Swift UI, if you want to move away from UI kit. All right, so that's just a brief introduction about what is structures. How do we define structures in Swift? Typically, we use the keyword struct, the name of the structure. In this case, it's a person. We have a capital letter. We have a curly bracket and a curly bracket, the beginning of the structure and the ending of the structure, similar to a class. The naming convention for the structures, we use the first letter as a capital letter. The struct obviously is keyword. For the attributes, and an attribute is something that belongs to the structure. Typically, there are two types of things that we include in a structure. Attributes, things that describe the structure, and methods, functions, things that the structure can do, all right? So if we want to define an attribute, how do we define an attribute? We define it just similar to any variable. So you'll have var, the name of the attribute. Attribute names are small letters, colon, and the type of that attribute, all right? If you have more, obviously, you will have more attributes, okay? Then how do we create a structure, an instant of that structure, and how do we access these properties? So this is the structure that we've defined. If I want to create a copy or an instant of that person, the way we do it, you just define it as just like any other variable, either let or var. Then you can say the person, a variable name, equal the name of the structure. So this is the name of the structure, and then between brackets, the required attributes. So here we have name only. So here you will have name, and then you pass the value. Now, if it is a class, you will have to create these initializers for yourself. In Java, if you remember, you had to create constructors. You had to create a default constructor and a non-default constructor. With the structures, these initializers are created for you automatically by Swift. So it looks at the attributes. We have one attribute here, name. So your initializer will have that attribute here. Later on, we're going to take a look at this and say, okay, what if I give it a value for these attributes? Then maybe they are not required to be passed to the initializers. How do we access the property? You're already familiar with that. We use the dot notation, the name, this is my copy or the object, and then dot the attribute's name. Since we have only one attribute here, that's the only thing that we can access. Right? Is that clear? Yeah. So in the next one, we're going to look at adding more functionality to it. Now, with functionality, just like I told you in the beginning, a struct or an object usually have things that we describe, which these are the attributes, and then things that they can do, and these are the functions. And in this case, we are adding a function or a method that belong to this person. Now we have an attribute called name. In addition to that, this person can say hello. So they can do, usually it's a function. So can say hello, and then it prints hello there, my name is, and then the attribute that you use to create this object with. All right. So now we have an attribute. We created the person, Jasmine, or the person with the name Jasmine. And then now I can say print or person dot say hello, not just simply print dot person dot name. I can call the function within that structure. And this is would be the output. Straightforward, right? What if you want to have more attributes? If you have more attributes, you just simply add those attributes here. Here we have a structure. What is the name of the struct? What is the name of the struct? Shirt. And what are the attributes? Size and the color. What are their types? Strings. So now when I create my shirt as an object, I need to pass both the size and the color for this one. Not only the size, because both of them don't have values, default values. I need to pass those in the constructor. So when we do this in the initializer, when we do this, we're creating an instant of that shirt. This instant is called my shirt. Another name to it is an object. So this object is called my shirt, and it's a copy of shirt. It has attribute of XLR and a blue color. Here's another shirt, your shirt, with size medium, and the color is red. All right. Obviously, you can add more methods if you want, not just simply one or two. You can, I mean, depending on these structure types or these structs, depending on their purpose, What do they do? So you can have as many attributes that meets the requirement of your application. All right. So in this case, we have a car. We have a struct called car. It has a make, it has a year, and it has a color, 3 attributes. Now, when I create an instance of those, if I create an instance of a car, how many attributes do I need to pass? If I create an instance of a car, how many attributes do I need to pass? 3, right? What are they? Make, year, and color, right? Now, in addition to the properties or the attributes, we have functions. Now, we didn't have the implementation of it, but you can imagine what it can do. So you start the engine is a function, the method. To drive is a method. Park is a method. Steer is a method. You notice that all these things are action, things that the object can do. So the things that an object can do or a struct can do, usually they are functions. All right. Now, when I create these, when I create instance of these cars, what do? I use all 3 attributes: the make, the year, and then the color. The make, the year, and the color. And then I can call any method available in these structures. All right. And then it's okay. Now, and the next one, initializers. You notice we already use initializers. How do I use them? Because when I did this, I'm using an initializer to create these objects. All right. You can create your own initializers if you want. I'm going to show you how to do that. But already these standard library types, such as a string, integer, Boolean, they already come with their own initializers. And these guys come with a default initializers. What does it mean? That means you don't need to pass any value to them. So in this case, they are omit. You can specify them if you want, or you can omit them. And I'm going to show you in the next slide how we omit this initializer. So when you define a string, for example, and then you put dot init, this initializer will be blank. When you say init.init, it will be initialized to 0. When you say Boolean bool.init, it will be initialized to false. You could specify it this way, or you can just omit all of this. So when you're doing this, it's doing the same thing that you saw on the previous screen, but without having to specify .init. All right. So by using these brackets here, you're actually calling the initializer. And this is typically how we create objects. All right. So this is how you can do shortcuts to create objects. Sometimes you need to define attributes, and it's okay not to pass a value to it. So you can specify a default parameters. For example, when you buy a car, first you buy a car, the odometer, do you know what odometer? شو معنات odometer? العداد اللي بالساعة. Okay, when you remember, say buying car with 0 miles or 0 kilometers. So when you first buy it, it doesn't have any miles on it, and that is okay. Why? Because as you're driving this car, that mileage or the kilometers will increase, right? So in this case, when we create a struct odometer, the initial count of this is equal to 0. And that's fine. So when I create an odometer value or an instant of it, I don't need to pass the count. You see that? So what will happen in this case? Because I gave a default value to this count of equal to 0, when I create this, the count will have a value equal to 0. When I print it, it will have a value of equal to 0, right? Is that okay? So what default that if remember this, if a struct has a property or an attribute with a default value, you don't need to pass it to the initializer. But you can still do that if you want to override the default value. How do we do that? Same previous example. Now I want to set the odometer to 27,000. It's not 0 anymore. I want to set it to 27,000. So now when you create it, it will have a value, that count will have a value of 27,000. So optional values, parameters, remember initializers, you can have, if you give it a default value, you don't need to pass it to the initializers. If it doesn't have a default value, you must provide a value for it. Okay? Let me pause for a minute and ask questions if you have any questions. Okay. So if we look at, so that was one example, and this is the other example. So what happens here, for a person name, you can't really have a person without a name. So in this case, you cannot have a default value for name. So if you need to create a person, you have to pass the name of that person. So in this case, when we say person, name does not have any value, default value, so I need to pass it to the initializer. That's the difference. So it depends on your structs, it depends on what their purpose and what are used in your they are used for in your system. Sometimes they could have default values, but sometimes you have to pass a value when you create these objects. All right. So this slide shows two structs. This one is my shirt, and we pass 2 values. This is my car, and we pass 3 values because this one has 3 attributes, this one has 2 attributes, and none of them has default values. So we have to pass all attributes to those 2 structs. But you could, as I told you, you could actually define your own custom initializers. This example shows you represent a temperature. And this temperature struct has Celsius temperature in it. So if I need to create it, I need to pass the Celsius value to it. All right. So what if we want to use the Fahrenheit? I don't want to create it with the Celsius value. I want to create this temperature using Fahrenheit. But I cannot use this structure as is. Why? Because I have to convert the Fahrenheit value to Celsius value, and then we can use this, we can create an instance of this structure. So if you look, if somebody gave me a Fahrenheit value and not a Celsius value, what do I have to do? I will take this Fahrenheit value, change it to Celsius value, and use this equation. Then we use new temperature equal temperature with the Celsius value that we calculated. That's a messy way of doing it. Every time somebody gives me a Fahrenheit value, I have to go through the process, convert it, and then create the temperature instant or an object using the calculated Celsius value. So maybe there is a better way to do that. And that's what we're going to see in the next one. So instead of creating only one initializer, I have 2 initializers. I have an initializer that you can specify, you can pass the Celsius value, and we say self.celsius equals Celsius. Notice we are introducing a new keyword here, self. Why do we use self? Just like in Java, you use this. Why do you use self? You use self because the name of the attribute, the parameter, is the same name of the attribute. So in this case, you need to distinguish which variable or which attribute you're referencing. So I'm saying self.celsius, I'm referencing the attribute in the struct. Equal Celsius, the value that is being passed to me. All right. So this constructor will receive a Celsius value. This constructor will make it more flexible. You can create still a temperature with a Fahrenheit temperature, and the class or the structure will convert it for you. This initializer will make all the necessary conversion and store the Celsius with the computed value. So here it says init Fahrenheit. This is the parameter is being passed. Celsius, we don't need to reference self here because the attribute that's being passed to me here is different. It's called Fahrenheit. So it's Celsius. I'm referring to the attribute in the class or the struct. I keep saying class. Then I say it is equal to the equation to convert it from Fahrenheit to Celsius. So now I can create, I have more flexibility to create temperature struct. I can use either Celsius or I can use Fahrenheit. And if you use Fahrenheit, it will convert the temperature for me and will assign it to the attribute in the class, in the struct. All right. And that's what we did here. Current temperature, you can use Celsius. Boiling temperature, this is the Fahrenheit value, and then you can print both of them, print current temperature .Celsius, print boiling temperature .Celsius, and it's 100, even though we passed a Fahrenheit we use this Fahrenheit initializer with a value of 212. Clear? Now, what you should do, because again, you've done this, so I'm not gonna, you need to go and then use the playground and practice what we've learned so far, all right? Next, we're gonna talk about methods. We talked about functions before. You can add functions to your class, to your structure, and they can return value just like other functions, and they sometimes don't return any values. So we have here an instant, we have a struct called size. It has the width and the height. We have a function called area. So it will calculate the area and return a double value. So if I create some size equal width and height, if I want to print the area, all I have to do is say let area equal some size, the name of the object, and then that area, the function, and that will return whatever you pass to it, which is 10 times 55. It will be returned and stored in area, which will be 55. All right. Mutating methods, you're not going to see this a lot now, but later on you'll understand what it means. Mutating methods means if you cannot change the attributes of a class structure directly from another method. So what you need to do, you need to create, if you are defining a method that is going to change an attribute or a property in the struct, you need to use that keyword mutating. All right, just remember that. So if we wanted to have a function that increment the odometer, I'm driving, so I want to add to the mileage or the odometer, then that method increment should have a mutating keyword, and that's what you're going to see next. So here is an odometer. It has count. We've done that before. It's initialized to 0. Now, if I want to change the value of that count within this function increment, I'm adding 1 to it, I should have that keyword mutating. In Swift UI, there are things called state attributes, property wrappers. You will learn about those later on. But for now, just remember this. If you have a function or a method in your struct, and that function or a method changes the attributes of that struct, you need to have a mutating keyword in front of that function. So you have a mutating keyword here because it's going to change the count. You have mutating keyword here because it's going to decrement, and this is going to increment, and this one will reset it back to 0. It would be nice if you have a car where you can change the kilometer on it, the mileage, huh? So instead of 100,000 miles, you can make it 0, brand new car, and then you can sell it for a higher price. Cheating. I'm not teaching how to cheat, okay? Last thing that I'm gonna cover, I think there's a few more, but there's one mutating, there's computed properties. Computed properties are very important. Struct means you don't have to have a function to calculate things for you. You can have a property that calculates things for you and just simply return the value. It's not stored. It's not stored in the data type. It's just simply whenever you reference that property, it will give you the calculated value based on the equations that you have specified. So in this case, we have a struct that has 3 attributes: Celsius, Fahrenheit, and Kelvin. But I know I can retrieve, if I have one of them, I can calculate the others. If I have Celsius, I can calculate Fahrenheit. If I have Kelvin, I can calculate Celsius. If I have Fahrenheit, I can calculate Kelvin. So why do I have all these different initializers where I can just simply have calculated attributes and it does the rest for me? So to create an object of this temperature, I will have to pass all these 3 values. And then 0 is in Celsius, equal 32 in Fahrenheit, equal 273 in Kelvin. But I can derive all of these by simple equations. So if you look at the modified struct, notice that you have these structures, these attributes. Now I have init with Celsius, init with Fahrenheit, init with Kelvin. More flexible, but there's a lot of repeated code. But notice that in each one of them, I will have to calculate the Fahrenheit and the Kelvin. If I created with Celsius, if I created Fahrenheit, I create Celsius and Kelvin. If I created with Kelvin, I'll calculate the Celsius and the Fahrenheit. All right? That's a tedious process. How can we do it better? Here is how you could do it better. Instead of creating an initializer, you can still do that if you want. Or you can just say, I am creating a structure. This structure has one attribute called Celsius, and I have a calculated property, var, Fahrenheit, double, open, curly bracket, close curly bracket, and the equation that you use to calculate the Fahrenheit value. So if you have set the Celsius correctly, then when you just simply reference Fahrenheit, it calculates it and display the value. So here is the current temperature, equal temperature. I'm creating an instant of temperature with the Celsius of 0. If I just simply print Fahrenheit, I'm accessing this computed property, it will print for me the value of Fahrenheit. All right. Here is a challenge you can do, how to change this, how to add Kelvin to it. The solution is here. You just simply put Kelvin as another computed property, and here is its value. Last thing, I think is very, I keep saying last thing. So there's another thing that we need to talk about here. Data types are copied. They're not like in Java, when you create a class, an instance of an object, if you say this object equal to another value, you're still referencing the same object. With struct, you're creating a new variable, a new type. That means if you change one, it does not change the other. They're totally different copies. All right. Here's the example. So sum size equal width 250, height 1000. Another one, I assigned it this copy. But now those two are different. They're not the same. They're not the same reference. If I make change to one, it will only take effect in that object only. It does not take effect in the other one. So here I say sum width, which is this one, I made it 500. This one still have 250. This one now have 500. When you print them, one will have 500, the other one will have 250. So here we'll say print sum size width equal 500. Sum size, because I changed it to 500. But this one still have the old value, which is 250, because I did not change it. Just remember this, assigning a variable to another struct instant, it means that you have another copy. They are not related anymore. All right? They're not referencing the same thing. حكينا عن الself already. If you use self, means that you're using a parameter that with the same name of an attribute in that structure. All right, we talked about that. Here is another when it's required when you actually again not required when the property does not exist within the same object. Okay. When it is required, Celsius and Celsius, they are the same, so it's required. That's it. All right. And let me stop recording.